Hello everyone, hope you all are doing well. So as you all know, or maybe you are new to the list or channel, then we are solving a linked list right now. We started with the Leetcode crash course that was introduced recently, but the number of problems here are pretty less to cover all the concepts. So we have created our own filter which covers most of the concepts. We have shortlisted 22 problems related to linked list and doubly linked list, and we are solving that one by one. And in this video, we are solving the problem number 2, remove nth node from end of the list. We have already solved some more problems and I'll be adding that to this list as well. So yeah, the problem statement says that given the head of a linked list, remove the nth node from end of the list and return its head, right? I would say again a trivial problem, but let's see how to approach this type of problem. So suppose I have a list. Let's call it 1, 2, 3, 4 and 5, right? I have a list and I'm told that remove the, and suppose n equals to 2, so the total number of nodes is 5, and someone says that remove the second last node from this list, right? And what is the second last node? So this is the last node and this is the second last node, so just remove it, and what you will get is 1, 2, 3 and then 5. 4 will be removed, right? 4 will be removed. So this is what the problem is saying. And again, let's take the second case. Suppose you have a list which is like this. You just have a single node and someone says that n equals to 1. That means remove the last node from the list. So this is the only one. You remove it and you return null, right? So yeah, these are the some of the cases that we can have. Now let's see how we can approach this type of problem, right? So on this channel we have already discussed one problem, relate a similar problem where what we were given is, so we had a linked list, and what we wanted was, we wanted to delete the not delete but basically find the middle node. We wanted to find the middle node of this linked list, right? We wanted to find the middle node of this linked list. So what we did, we considered that suppose there is a straight line, right? And suppose there are two people, person 1 and person 2, and this length is L, right? This length is L. So in case they both start a race and the speed of the person 1 is x and the speed of person 2 is 2x, right? So how much time will person 2 take to cover this length? It will be t, let's say t. So t will be L by 2x, right? L by 2x. So after t time, this person 2 will reach here. Now in the same time frame, how much distance will person will cover? So distance is equals to speed into time, right? Speed of person 1 is x into what is the time? It is L by 2x. We replace it here, x cancel, so that is L by 2, right? So it means to say that if two people are moving, or in our case, so these concepts are related to slow and fast pointer, right? Slow and fast pointers, right? Now what it says that in case two folks start or either a slow or a fast pointer start at different speeds, then what is the relationship between them? So if a fast pointer is running at a distance of double the slow pointer, then when this pointer reaches the end, this guy will be at the middle of the list. So we take a pointer which jumps 2 position at a time, and we take a slow pointer which jumps just 1 position at a time. Now when the fast one reaches the end, then actually what happens, the slow one is at the middle. We saw it mathematically here, right? Now this problem is exactly not related to slow and fast pointer, but a similar concept, right? Now how the concepts are similar? So suppose I have a list, or suppose I have a straight line, right? And what the problem says is that suppose I plot as point 1, 1, 2, dot 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 and end point, right? Now the problem says that you need to delete the, suppose, nth node from the end. Suppose this is the nth last node that I want to delete, right? Now just see what is the distance between these 2 points. Which points? The nth node and the last node. Suppose this distance is d, right? Suppose the distance is d. Now the basic thing that I can do, the brute force approach would be that I traverse the list and I calculate the number of nodes in this list. Suppose the total number of nodes is capital N, right? Then what I do, I calculate what is the number of this node. Suppose the total node is n, so I do n minus n value that is given in the problem, and I again traverse my list and basically come to this node. And what I do, I pick up the node just previous to this and I point its next to the node just after it, right? This is the basic approach that I can do. But here what is happening, I am doing the traversal two times. Now, is it possible to solve this type of problem in just one traversal? Let's see that. So, as I told you, this is the last node and this is the nth last node, and the distance between these two is d, right? Now, obviously, similar to the slow and fast pointer concept, if somehow this d distance is moved on the left hand side, right? I can have two pointers. Suppose I have one pointer p1 here and one pointer p2 here, right? So if somehow I have two pointers and distance between these two pointers is d, then whenever my second pointer will reach the end of the list, then my first pointer will obviously be at the correct position which I want to delete, right? This is very much obvious. Now what I can do, let's backtrack this, right? Let's backtrack this, because I don't know what is the last node. I have to traverse it to know the last node. Can I use starting position to find this relationship? So what I can do, this was my straight line, this was my last node, this was my nth last node, this distance was d. Let's backtrack it. Now what happens, this node, let's call it n1 and let's call it n2. N1 is the node that I want to delete, n2 is the last node, right? Or basically let's assume these two are certain pointers. Let's call it pointer 1 and let's call it pointer 2. So initially pointer 1 is pointing to the node that I want to delete, pointer 2 is pointing to the last node, right? Now what I can do, if I backtrack it, and let's assume that n1 is pointing to the starting node, right? N1 is pointing to the starting node. So at a distance d, sorry, this does happen to me when I, let me just select this. Now if n1 is here, and suppose I talk about at a distance d I have my n2 pointer, then don't you think this is the same relationship but between just two different nodes? Here n1 is the starting node and n2 is at a distance of d from here, right? We have just backtracked it. We have just moved these two pointers x distance. Suppose this distance is x, then this distance is also x, right? Now what I can do, I know which is the starting node, I know what is this distance, so I know what is this node, right? I know the starting node, I know the distance d that is given in the problem, because it tells me delete the nth node from the end. So I can detect what is this node, right? So I know these three things. So once I know this one and this one, similar to the concept that I used in the slow and fast pointer, what I can do, instead of moving at a different pace, I can move these two at the same pace, right? One step at a time. I can move these two one step at a time. Now what will happen, similar to the case that I discussed above, when n2 will reach the end, node, or at the last of the list, n1 will reach the node which I want to delete, right? Because the distance between them is d. I started from here and the distance between them is d, right? So what will happen, n2 reaches end, n1 is the node that I want to delete. So yani what I did was I backtracked and I started from the starting node. All I can do is, I know that there is a pointer, I can keep a pointer to node that is just behind this n1, and I can make the next of this node point to the node that is just after n1, right? And this node is deleted, right? So this is the basic approach that you try to follow, right? And this will be the approach for this problem. I've also told you how to basically form the intuition for this one. Now just one more thing, in many codes that I'll be showing you, I have taken an extra thing, and I'll tell you why I've taken that extra thing. So whenever you are given the head of a linked list, right? So what I generally do is to tackle the null cases. Suppose your list is null or something like that, I add a dummy node here. So this is my dummy node, let's call it d, and this dummy node now points to the head of the linked list. Now what flexibility it gives me is that whatever operation I want to do on my list, I do it, and at last I just return d dot next. I need not do a null check or something like this, right? So that is why I just do it. This is just for making the code more clean and avoiding some of the if else conditions. So that is why I'll just show that into my code as well. So if I come to the solution, you can see what I told you on line number 13. I have created a new node, and the next of that new node is pointing to the head, right? Now line number 15 says I have an end node. Now this end node is basically, I'll move this end node at a distance d from the starting node, right? So you can see start and end on line number 15 and 16 are pointing to the start node or the head of the list or the new node that I've created. Now I run a loop and I make the end pointer move at by d distance, right, or end distance in this case. So now what happens? The distance between my start and end node is n, that was given. Now I run a loop while end dot next is not equal to null on line number 20. Start moves one step and end moves one step, right? Basic stuff, right? Now when end moves to the end, this the start will be pointing to the node just before to a node which is just behind the node that I want to delete, right? And then on line number 24, what I'll be doing start dot next equals to start dot next dot next. That means the node that is just behind the node that I want to delete, its next will point to the node just after the node that I want to delete, right? And finally, as I told you, instead of doing some null checks and all I do on line number 25 is return new head dot next, and I'm good to go, right? So yeah, I hope you learned something new from this video. Do let me know in case you have any queries in the comment section. Also, if you find this channel useful, do subscribe to it. It helps me keep motivated, and we'll be solving more and more problems together. So yeah, do let me know, and yeah, take care. Bye bye.